Thank you for being here today for the tour. My name is Tom. I'm one of the volunteers who looks after the tug and does tours. The tugboat Edna G was built in 1896 by Cleveland Shipbuilding at the express order of the president of the Duluth and Iron Range Railroad, and it was built to his specifications. The use of this tug was for bringing ore boats into and out of the harbor here, and at that time most of the sailing vessels were still wind powered, and sometimes they would be towing a non-powered barge. There was, of course, steam power at that time, side wheelers and some with an actual propeller on the back end, and these vessels would also likely be towing a non-powered barge, which was simply a sailing vessel that had its masts sawn down, and they had a minimal crew just for tending the lines. So the tug is all steel construction, which was a kind of a novelty at the time. Most of the tugboats that were built for Great Lakes service may have had a steel hull, but not unusual for them to have a wooden hull either. But the decks and the main deck cabin and the pilot house would have been generally wood construction. This one was all steel from the keel up to the top, and they had different paint schemes over the years. The earliest ones had a faux wood finish on it, so it looks like it's a wooden cabin, but it was steel, just painted in the appearance of wood. The tug is about 110 feet long, and it's about 23 feet wide at the beam. It draws 13 to 14 feet of water, depending upon how heavily the tug is loaded. Right now there's no coal on it, so it does ride a little bit higher than it otherwise might. It would usually carry about 75 ton of coal on a full load. So Edna G was the name of Jacob Greatsinger's daughter. Jacob Greatsinger was the railroad president at the time, and so, well, you know, being the railroad president and they're building the boat for you, you have the power to give it whatever name you want, and Edna was the apple of his eye, so Edna G is the name of the tug. There was an earlier tug working here in the port of Two Harbors. It was the Ella G. Stone, no relation to Edna G. That tug was all wood construction. It was significantly smaller than this one. The railroad president could see that loads were going to be getting bigger and heavier as the industry grew, and so he wanted a tug that was big enough and powerful enough to do the job without straining. So before we go on board the boat, I'll explain one or two terms that I will be tossing about rather casually during the length of this tour. You notice that I call this a boat. It's common usage on the Great Lakes. Anything sailing the Great Lakes, it's a boat, not a ship. Even if it is a ship, it's a boat. It's semantics, it's linguistics, it's custom. The tug is a boat, 1,000-foot or quarter-mile long ore carrier. It's a boat. We don't have any salties coming in here, so I don't have to worry about insulting any of their crews by calling their vessel a boat. What we do is sidestep it. We don't call it a boat, we call it a salty. So there's that. But the surface that we stand upon and walk on board the boat is a deck, not a floor. Even if it's down in the captain's cabin with a wooden floor, it's still a deck. The vertical surface that you would think of as a wall is a bulkhead. Of course, bulkheads have doors in them, just like walls do, but we have windows and portholes. That's not terribly important. Hatches in the deck to let us go from one level to another, but we don't be doing any of that. Our hatches are for the coal bunker and the chain locker mainly, so we won't be going through any hatches, but we will be going up and down several ladders that look just like stairways. Anything we climb up and down on is a ladder, even if it looks like steps. And so with that said, I suppose we can go on board. And one thing to remember whenever you're on board this boat is keep one hand for yourself. Always hold on to something, because the boat and the lake are both patiently waiting to end you. So don't ruin a perfectly good day by falling into the lake. We'll do our best to fish you out, but just hang on and we don't have to worry about that. Now remember, as we board the boat, I'll step aside to make sure that you don't make a misstep. As you get on board the tug, then just go aft and we will meet at the back end of the main deck cabin. Come on. So we'll start the tour here at the aft end of the tug, and I will explain some of the things that you're seeing back here. I'm going to climb over this mooring line. I do not expect you to climb over it as well. It can be a little bit tricky depending upon what your agility is, and so just bear with me. So what we're going to see here is the part of the rudder that we can see, and then I'll show you the winch and Samson posts for mooring and explain a little bit about how a tug would handle towing from astern, especially in bad weather. So right off, might as well start right at the rudder and continue from there. What we're seeing here on the deck near my feet is what appears to be a tiller from a sailboat or something. Well, it is, we could call it a tiller arm if you want, but you're not going to actually be doing any steering with it. But it is connected to the rudder post, and this arrangement that we see here with these cables on here is to keep the rudder from moving freely while the tug is moored and not actually doing any work. It prevents damage to the rest of the steering system. When the tug is used, these cables will be removed, and if there's steam up, then the rudder will respond to the controls of the pilot up in the pilot house. If it were an emergency and there was something wrong with the steering gear, that it had no control over the rudder, we could hook up block and tackle where these fixed cables are now, and we could have some ability to move the rudder somewhat, but because of the power required to actually move the rudder, if it were under load, it would be just for steering the tug itself or minimal steering controls. So this hatch that you see on the deck here beneath the rudder arm is originally an escape hatch for the crew if the crew's quarters were used as a berthing space. There has to be 2 ways out of each compartment, and that would have been one of them. There were changes in the way the tug was operated over the years, and since the crew's quarters was not actually a habitable space anymore, there was no concern about having a second escape means, and so the hatch was secured so it couldn't be accidentally opened when the tug is working. So that's why it looks like it's welded down. So the next thing we're going to show you is the Pelican Hook on the main deck here that was part of the tackle used for towing from astern. So what we see here is this massive steel casting attached with a very, very sturdy bit of chain. This was called the Pelican Hook and would have been used as part of the tackle for towing directly from astern. So imagine, in your mind's eye, if you will, an oar carrier behind the tug, and the bow is up in the air quite a ways, and the mooring line for that is coming down at an angle, and it'll have a loop on the end of the line. It will go through this Pelican Hook. So this Pelican Hook, once we take a strain on it, will be up off the deck, and it will be up at an angle pointing at the bow of the tow that's behind us. So Lake Superior has a reputation of being pretty severe sometimes, and things can change rather quickly and dramatically. So there is a way of disconnecting from your tow if it's necessary for the safety of the tug and for the safety of the tow. Remember, this is under considerable strain here, and this is up at an angle. The person who is working the deck, that'd be the first mate, would come out here with a long-handled sledge, and then he would lift this pin from the bill of this Pelican Hook so that this clevis is then free to move, but it's under considerable strain. and it's up in the air, as I said, so he will stick back what he figures is a safe place out of the way, and he'll take his long-handled sledge and he will strike this clevis, knocking it in that direction. As soon as it gets to this rounded part here, the forces acting on this Pelican hook will cause it to violently swing open and release the line from the tow. And so this is a very dangerous operation because there's a considerable amount of force on this Pelican hook, and it's going to fly around rather violently. And so the person has to be rather nimble as he strikes that clevis. He also has to get himself out of harm's way as this thing flails about violently. So now that we've got an understanding of what this Pelican hook is about, I'll go over here in this other corner of the main deck cabin and I'll talk to you about this winch or windlass or capstan, whatever language you prefer to use. And we'll talk about these hitching points on the Samson post and a little bit about the mooring lines. So this equipment that we're looking at here is a steam-powered capstan, and it would be used for taking in a line from a tow or to help bring the tug closer to the dock for mooring purposes. The deck line handler would be taking the line, make a couple of turns around this, keep attention on it as the power is applied to it, and it will wind in as long as you keep this slack out of the line that's coming off of the windlass. It's steam powered, and the controls are no longer mounted or readily apparent, so we just have to use our imagination a little bit. So what we're looking at here, after we've gotten this capstan out of the way, is the mooring setup for the tug. This is a permanent mooring situation, so it's not like we're undoing it and redoing it a couple of times a day. So what we see is a 2-inch nylon line and then a rather stout steel line with permanent loops on each end. And so we would call this the belt and suspenders school of permanent mooring. If one system fails, the other one is very likely going to hold. Oddly enough, during a bad storm, we did have a situation where the steel line parted and the nylon one held, because the nylon one is capable of considerable amount of stretching and giving, and the steel one was rigid and would not give, and it let go. The virtue of the bollard hitch is that it is easy to tie or bend, and it does not slip, it does not bind, it does not jam up, it just holds, and it's easy to undo and easy to redo. As long as we're here, we'll go check out the crew's quarters. It's not ordinarily a part of the tour for most people because it is a little bit difficult getting down there, and it's rather drab and dreary besides, and so it's not really all that nice to look at. But it is a fact of tugboat life. This door is a Dutch door. The top and the bottom half can open independently, and so it would not have been unusual to have the top half open and the bottom half shut. This lets air into the compartment, and with the bottom half of the door secured, it helps keep water out. This is, after all, a low-lying boat, and under some conditions there can be considerable amount of water sloshing about the deck. So now we're going to use this Dutch door as normal, ordinary, solid self door. So now I want to remind you that you are on a boat, and so this is designed not for the convenience of the people, but for the safety of the boat. The entry has a very high threshold. You're going to have to step up at least a foot. I'm going to go down first just to make sure that you don't have any mishaps when you go down the ladder. Remember, all stairways are ladders. This one is a very steep stairway, so it just might as well be a ladder. I'm going to go down facing forward, but when you go in, you can face whichever way is most comfortable for you. This space is called the crew's quarters, even though in ordinary working conditions in the last few decades of the boat's working life, the crew wouldn't have actually stayed down here for very long. Maybe to get out of the bad weather, or if it were a long shift, they could maybe catch a nap or something like that. But ordinarily, as a working day, they would come in, do their work, and then leave the boat at the end of the day and go home to their own little snug nest. So this is pretty Spartan. It's pretty grim. And it is representative, though, of 19th century berthing ethic for the ordinary seaman. The mattresses are not original, but the framework and the springs are. The things that we can look at down here will be the steam motor that runs the capstan up above. Directly aft, we can see the rudder post and the chain that's used for operating the rudder. We can see a lubricating device that's used for keeping the shaft seal lubricated. And I can lift a deck plate here so you can see the propeller shaft for the tug. So I'm going to use this light to point some things out to you. Part of our steering mechanism will be a rather powerful steam cylinder, which actually does the pulling on the chains that actually operate the rudder. They will run from the boiler room aft all the way to the rear end of this tug. The chains will run along the outboard side of the tug. This one is a little bit hard to see. You have to kind of look up at it. On the other side is a better example. So the chain runs from the boiler room all the way to the aft end of the tug, and it runs over pulleys as needed to change direction as the tug changes shape. I'll shine the light straight aft so we can see the steering quadrant, which actually operates the rudder. You can see here rivets in the hull plating. The Edna G was built all steel, but it was fastened by means of riveting because electric arc welding had not hit the greater industrial market in 1896. That didn't come along for another few more years. So this is all riveted hull. We keep the deck hatches shut so that we don't lose our visitors down in the bilge. So just bear with me while I lift up the hatch so you can see what the propeller shaft looks like and where it goes. The propeller shaft is solid steel, and when the propeller is turning, this shaft is also turning. Below the propeller shaft is the area that we would call the bilges, and you may see some water down there as well. Well, this completes our visit to the crew's quarters. You've seen what there is to see down here. Let's go back topside and continue the tour. The holes that you see in the deck are called scuppers, or more particularly deck scuppers. The deck on the tug has a kind of a crown shape to it so that when water comes onto the deck, it automatically runs outboard away from the main deck cabin, and that's why the scuppers are placed next to the bulwark. The bulwark is a small wall that you see that's between the deck and the gunwale. And so there is a door in the bulwark. It's called a bulwark scupper, and ordinarily when the tug is working, those bulwark scuppers will be open because there can be large amounts of water on the deck. So you are now in the upper level engine room on the tugboat, and I'll point out a few things here that will let you understand just how well designed this engine room is for economy of personnel needs. I'm standing at the position where the engineer would be when he's actually running the throttles for the tugboat. And so we have here a couple of levers. So this lever is the throttle. It actually controls how much steam goes into the engine, And you can just follow this linkage and it takes you right over to the throttle valve. And you can see that moving as the throttle control is being moved. So that's where the steam enters the engine. And now to go either forward or backward, they would be using this control. It would be a reversing lever. It actually reverses the rotation of the shaft by reversing the direction of engine operation. So this is a compound steam engine. There are two cylinders that provide the power. The steam will enter the high pressure cylinder. It will do some work driving the piston down, and when it does, it's connected to a piston rod that's on the crankshaft down in the lower level. When the steam is done in the high pressure cylinder, there's still some energy left in the steam, so it then is directed to the low pressure cylinder where it can do some more work before being exhausted to the condenser. To know how fast to go, in what direction, the engineer relies on controls and instructions from the pilot house. This device is called a Chadburn. Its actual name is an engine order telegraph. You see an arm here that will move. It's controlled by an engine order telegraph up in the pilot house. Right now it's saying finished with engines, but if you wanted to go ahead at a slow speed, the captain would operate his control. It would make this pointer move over to this position here, ahead slow, and would also be ringing a rather large gong on here. The engineer, on getting that order, responds to it by moving his own control so that his pointer would be matching the captain's pointer, and the captain will see a moving indicator on his controller that tells him that the engineer has gotten the order, he's answering it, and he understands it. We're not using the engine, so I'll just put it in this position just because, well, that's the way I am. I'm sorry. This is a compound engine. Like I said, it uses the steam twice before it goes to the condenser. But when you look at the top of it, you say, well, it looks like there's 3 cylinders. Well, yes, it does look like there are 3 cylinders. This very first one is called a slide valve, and it moves up and down, and it has mechanical linkages connected to the other parts of this engine so that the slide valve knows just what the engine is doing. It is basically the brains of the engine. In modern day terms, you might think of it almost like a mechanical computer. So it knows when the high pressure cylinder is ready to receive steam, so it will be in a position to send that steam to the high pressure cylinder. When the piston has gone down, the slide valve will know that because of the linkages that are connected to it, and it will then direct the steam to go to the low pressure cylinder so that it can be used again. So although it appears that there are 3 cylinders, there are only 2 that are doing any work, because those are the only ones that have pistons that are connected to the crankshaft. This is about an 18-inch bore. This one is about a 40-inch bore. And when we look on this side of the engine, we see these different receptacles, brass, and they are lubricators for making sure that the moving parts of the engine get oil. That includes oil injectors for the pistons, and then grease for lower bearings. So we don't need a wiper down in the lower level of the engine room manually lubricating those things. It's all done from up here with these devices and these cups that you see on the side of the engine. This big brass thing you see here is the exhaust or outlet for safety pops. And so when it does go off, it'll shoot the steam straight up to the overhead. Of course, when that happens, that will be kind of a hazardous thing. You want to get out of here because it'll fill up with steam quite quickly. A portion of the forward bulkhead of the engine room has been removed on purpose so that you can see a portion of the upper part of the boiler. This is a water tube boiler, which means that each of these things is a cover over a tube in the boiler. The water, which is turned into steam, is in these tubes. The heat from the firebox in the boiler rises up and flows around these tubes to heat them up for the purpose of making the steam. This object is a sight glass, which tells us what the water level is inside the boiler. We should not see any water in it right now because this has been deliberately drained dry, but ordinarily they would keep the water level between these 2 points here. They don't want it to be too low because then you have a possibility of injuring the boiler, and if it's too high, then water can carry over into the steam, and that can injure the engine. So I said that this engine room was designed for efficiency of operation. You've already seen how the engineer can take care of the lubrication needs down in the lower levels, so we don't need a person down there. The next thing that you will see is this bank of valves on the aft bulkhead in the engine room. Those are used to control 4 different pumps that are in the lower level, and we don't need anybody down there to turn them on because they can be controlled with these valves up here. It's a combination of steam and water, and I'm not going to point them all out individually because, well, I can't. I haven't sorted them all out, but I have looked at them and I can see they're labeled for various pumps, and I can tell which ones are steam lines and which ones are water lines, and so I can see this engine room can be controlled completely by one person up in this level, and that saves the cost of a whole another employee down in the lower level. So again, we have the steam injectors that bring feed water into the boiler. These other valves are used for controlling feed pumps, bilge pumps, and for other pumps that we have on here, including the one for the monitor or water cannon. This device that's standing up from the deck in front of me here is the top end of the condenser. The rest of it is all down below, and we will actually go down there and we can point out some of these things. This is what will be turning the steam back into water, and this does 2 things. It makes the water available for reuse again, plus it helps maintain the vacuum on the exhaust side of this low pressure cylinder, again improving its efficiency because you're using more of the pressure. This pipe that you see rising from the lower level engine room goes straight up and then across and through this short bulkhead. It continues on to the monitor or water cannon that's used for firefighting. The engineer will know when it's time to use that because this little brass bell will be sounded by the first mate when he's upstairs, when he's topside, preparing to use the monitor. He will ring this bell that will tell the engineer that he's got to line that up for operation to start the pump and then make the water run. The next thing we'll do is we'll go below decks into the lower level engine room, which most people do not get to see just because of the difficulty of getting down there and the crowded conditions. So we can go down the ladder. We've got grab irons on both sides. Always have 3-point contact going down, especially if this tug were actually working and it was on the lake and was swaying back and forth. You want to protect yourself. As long as we're in this part of the engine room, we might as well talk about what we can see from this location. Right behind you is a water pipe that goes up through the engine room and goes up to the monitor that we had talked about earlier. The water for that monitor comes from this location over here. There's a valve that's attached to this pipe that comes from the hull, goes through this valve, then this big fat pipe with these 3 knobs on it. Then it runs into this turbine pump, and from that turbine pump goes out and up this pipe. This turbine pump is driven by this turbine. It's a steam-driven turbine, and it's the only turbine on the tug. Everything else is reciprocating action with pistons. This pump will deliver 3,000 gallons of water per minute at a fairly high pressure. The next thing that we see over in this far corner here is a steam-operated pump, which is used in part of the feed water system. Right behind you is the rest of the condenser. It's called a jet condenser. The upper portion is a bottle shape where the steam comes in and then cold water from the lake is sprayed into it and it causes that steam to condense. It flows to the bottom part of the condenser where it's collected and pumped back into the feed system. So now it's time for us to go and look at some of the other hidden treasures down here. I had spoken before about some of the mechanical linkages that operate the slide valve so that it knows what condition the various parts of the engine are in. This is one of those linkages that operates the slide valve and moves this shaft up and down to direct the steam at the right time to the right destination. Again, I haven't traced it all out. Part of it is a cam on the drive shaft or propeller shaft, whatever you want to call it. This toothed ring here is what's called the jacking gear. We'll see that it's engaged with a worm drive and up to this shaft that would operate with a large wrench. If you wanted to manually rotate the engine when there's no steam, you have to check bearings or check the alignment on something. You can do that with this jacking shaft. In this corner is a small pump. Again, it's operated by steam. We have a couple of steam cylinders and we have a couple of water cylinders. On this side will be steam. This is a lubricator for the steam parts. And these pistons will go back and forth and it'll move these pistons back and forth for pumping the water. This is on the suction side and it's down in the bilge, so if we had to, we can use it for pumping the bilges. If we operate some other valves differently, we can take a suction from Lake Superior and deliver the water to a hydrant up on the main deck for delivering water to another boat that may need water for one reason or another. Maybe their feed water system is low or they need some more water. We can deliver water to them with this pump. Here we have the gallery for the connecting rods that are being driven by the pistons. And we had talked about the value of being able to lubricate the engines from up above. On other steam engine driven vessels, there would be a watch stander down here called a wiper, and it would have greasy or oily rags reaching in and manually lubricating these sliding parts on either side here while the engine is running. Very dangerous, very hazardous, especially in a small boat like this. It could be rocking back and forth, sometimes almost violently. So we see some of these smaller oil lines here. They're all from those lubricator cups up above that we had pointed out earlier. This is a well-designed engine room. It's for safety as they understood it then, and efficiency as bookkeepers have always understood it. Down below here we see the counterweights for the crankshaft, which actually rotates the propeller shaft. Okay, there are plenty of things down here to see, and I will freely admit that I haven't sorted everything out yet myself, but we do have another water pump here. It's driven by steam, 2 cylinders for steam and 2 cylinders for water. But exactly what it is right now, I cannot tell you. It'll be part of the feed water system. That's as much as I can say. This big container behind me would have been for preheating or conditioning the feed water, so it's not such a shock to the boiler. It'll have some steam lines running it to kind of warm up the feed water a little bit so that it doesn't affect the pressure in the boiler too seriously. You will see some lubricator cups down here that were also used for lubricating various bearings. The rather stout looking pipes here runs down to journal lubricator cups. We can see on top of this main shaft here, here's a lubrication point here, and another one there, and another one further back. And these can all be addressed from up above as well. I've shown you just about everything I can think of down here. I apologize for my incomplete knowledge of how this engine and its components work. There are no surviving Edna G engineers who can come down here and tell me about any of this stuff. So whatever I know is from what I've learned from just tracing out the piping myself. What you're looking at now, I'm at the face of the boiler where the stoker would be working. He has some coal bunker doors behind him here where he would get his coal and then shovel it into the opening of the boiler. So there's one here and there's another one here. You're looking at one of the doors to a coal bunker on the port side here. And now we're looking forward, and then behind these screen doors here is another opening to the other coal bunker door. During the summertime, they could put these screen doors on the open doors of the tug and get a little fresh air ventilation. We don't normally show anybody anything down here just because it's not cleaned up and there are some issues to be concerned with. This is looking into one part of the boiler where the coal would be shoveled into. And then this is looking into the other part of the boiler where they would be shoveling coal into. There's more than just shoveling the coal in. It has to be banked and heaped, and the fire is actually built. Looking up here, this cylinder that you're seeing, pardon the glare, this is the steam cylinder that actually operates the rudder by pulling on the chains that you saw in the earlier part of the tour down in the crew's quarters. The top part up here is the steam dome, which is the very top part of the boiler where the steam gathers and is drawn off to be delivered to the engine. This particular boiler was built in 1948 and installed in 1949. It's a Babcock and Wilcox water tube boiler built for the Edna G. So let's go up topside and continue the tour and see the rest of the tug. The history of the tugboat Edna G is delicately woven into the history of the state of Minnesota, iron mining, transportation of iron, and the fighting of every war that we have been in since the tug was built, plus construction of America itself. If it used steel, there's a good chance that the iron ore came from two harbors. Therefore, I like to claim that Edna G helped build America and helped fight her wars. During World War I, the War Department federalized the tug, took it out to the East Coast through the St. Lawrence Seaway, and the tug handled war material on the East Coast for the 2-year period that the U.S. was in World War I. In 1919, when the tug returned to Two Harbors, she was beat up, dirty, and the bronze eagle on the top of the pilot house was gone. We don't know who took it or when. We have this Uncle Sam casting on the back bulkhead of the tug, and there are some who say that it appeared during the tug's service on the East Coast. I do not know, I cannot say for sure. It is the upper part of a carnival novelty machine. You put a nickel in the machine and shake hands with Uncle Sam to test your grip strength. See what kind of a man you are. And so this is just the upper finial part of that machine. There are different variations on the design of Uncle Sam, the color scheme in his hat and in his torso. And there are some subtle variations in the shape of his face and his beard. If you're an avid collector, you could do the detective work and find out just exactly what machine this came from. I don't have those resources or the ability to sort it out. The machine was first appeared in American carnivals in about 1908. There are reproductions available today that cost several thousands of dollars. This is just the head. It's cast iron and it's mounted on the bulkhead, and so when the last captain retired, the head was given to him as a kind of a going away present, and some years later he and his family decided that it should be returned to the tug as they considered it to be part of the tug. I don't have any more details beyond that. When I had talked about a pump downstairs that would deliver water to a hydrant on the deck for water service to another boat, this would be that hydrant. We've seen what we can see here. Let's go forward and up into the lunchroom and continue the tour and one or two little stories there. On the way, I will be stepping over a couple of deck hatches that would have been used for taking on coal when they needed to. We're standing right above the coal bunkers on either side of the tug. I've been on my feet for a while during this tour, so I'm going to take advantage of the opportunity to sit down here in the lunchroom. Remember, this tug was built in the tail end of the 19th century. There were certain standards, ideas on what is proper and what isn't. And at this time, this tugboat had a lunchroom and a kitchen, and the company provided a full-time cook for the crew. This was the tail end of the 19th century and into the early decades of the 20th century when this condition existed. As you can see in this video, the lunchroom is paneled in a nice hardwood paneling. Sometime in the intervening years it had been painted, and earlier restoration work had removed the paint and exposed this paneling. It still needs a little bit of touch-up work and maybe a little bit of TLC, but this is a work in progress back to the history of the tug. The crew had meals provided for them by the cook. Cook was paid for by the company. Some of the cook's skills were a little bit uneven. Sometime during the 20s, the cook was so bad that even in the logbooks for the tug, they talk about this cook's crimes against food. And he had an on-again, off-again relationship with the crew and the tugboat and the company. And the logbook reports that in his final exit from the tug and railroad employment, that the crew celebrated, and the remarks were that there would not ever be another cook again in the tug. So the crew provided their own meals. They referred to it as their nose bag, because that's what a horse was fed with, and so that was the language at the time, and that's the way it's recorded in the logbook. This table is fastened down to the deck. In the galley, we will see that the cabinets are arranged in such a way as to hold the dishes and crockery in place when the tug is rocking and rolling. We see round windows in here, or portholes, but the framing around them is square. In 1917, the company installed these steel windows. There was originally just wood frame sash in here and wood frame doors, but then before World War I, the company spent money and put the steel doors on the tug that we see now, and these steel framed porthole windows in this forward cabin. Let's go into the galley and I'll show you a few things there. You'll see some radiator in here for steam heat. The railroad yard had complete shops for every industrial trade. They had machine shops, they had foundries, they had forge, blacksmithing, giant lathes for railroad wheels, smaller lathes for smaller things. When repair work needed to be done on the tug, it was done in-house with the employees that the railroad had and their skills. That does not obtain now. But let's go into the galley and we can show you what's what in there. Well, we're in the galley on the tug, and common with ships and boats everywhere, nothing is level. The forward end of the tug is higher than the aft end. The deck in here slopes a little bit. So the cooks, they had to adapt to those kinds of conditions, but for them it was normal. We will see some features in the pantry where the cupboards are designed to hold the dishes in place when the tug is rocking and rolling. So aside from that, let's talk about what we see here in the kitchen. This is a wood-burning stove, but we're on a tug that's carrying 75 tons of coal, so they burned coal in it. You can do that, you just have to be a little bit careful and not get too ambitious with your heat there and burn the darn stove up. It has regular lids like you would find, and an oven, all the comforts. This could be lifted up for hot water, and of course the ever-present coffee pot. The sink provided water, but the drain would go directly overboard into the lake. Needless to say, none of this is used anymore and has not been used even in the last decades of the tug's service. We've got cupboards in here for some of the kitchen supplies, but let's go into the pantry and I'll just show you one feature of one of the cabinets, and you can see what I'm talking about for holding the dishes in place when the tug is rocking and rolling. So it's not mealtime right now. The tug is working and the lake is a little bit rough and we're rocking and rolling back and forth. Cook doesn't want his dishes getting scattered and broken and shattered all over the floor, so they're put away. We have a cupboard here that would hold the dishes. This latch would hold these doors shut. And inside we can see the provisions for storing all the dishes. They're made in such a way that the dishes won't fly out when the tug is rocking and rolling. Well folks, this concludes the tour of the lunchroom, the galley, and the pantry. So in the blueprints, this would be the passenger saloon. In the tail end of the 19th century, it had a little bit different meaning than what comes to mind now. It's not a public tavern where people go to drink. There's probably some drinking going on down there, but what it is a cabin of good quality for accommodation of passengers. You'll see when we get down there. Well, here we are. We call it the captain's cabin or the captain's quarters. That was its most common use in the latter part of the tug's life. In the earlier years, this would have been for VIPs, and it was a showpiece for the Duluth and Iron Range Railroad. This cabin is fitted out in railroad tradition of the private varnish for the railroad president. Private varnish in railroad terms. The coach would be fitted out with high-class paneling, luxurious lighting fixtures, probably an entire staff for housekeeping and cooking. Well, this is a working tug, but it was also a showpiece for the Duluth and Iron Range Railroad and the president of the railroad. There were times when company officials would bring a group of friends on board, and they would go for a little joyride on the tug, maybe go up to Encampment Island or some other scenic point, just for a picnic and a day of fun. When you're a high-ranking official, this is one of the privileges that you have. Also, this would have been done because the business of America is business, and there is a newspaper account of a U.S. senator and a U.S. congressional representative and a federal judge and some local officials from the Twin Cities area back in the 1920s who came up north to Two Harbors for a week-long fishing trip on the Edna G. Talk about money, they not only had the use of this tug for their fishing trip, but it also required renting another tug from the port of Duluth to come here to Two Harbors to do the Edna G's work while she's out taking VIPs on a fishing trip and a joyride. So sometimes business was business, but it was business. So we have cherry hardwood paneling in here. The floor originally had wall-to-wall carpeting, a high-density carpeting. These would have been upholstered either in leather or mohair. They've since been reupholstered by the railroad because of wear and the passage of time kills even the best upholstery. We'll go forward here into the bunk room. We spoke of the cherry paneling in the lounge area here. In the berthing compartment, we have some nice oak paneling. The bunks in here are original. The bedding is original. The sheets are original, as the lighting fixture also. This is the actual carpeting that was in the main lounge area of the passenger's saloon. This is the remaining piece. The rest was damaged by water from leakage from the escape hatch. This is the manufacturer's mark that's woven into the backing of the carpet. When I was talking about water leakage from the escape hatch damaging the carpeting in this compartment, this was the escape hatch if you were not able to exit by the ordinary way that we came in. There's a metal hatch up above, and this bolt would be loosened up in order to allow the hatch to be opened. And so the seals were damaged, and it allowed a considerable amount of rainwater to come in here over the decades, and that's what rotted out the carpeting in here. No high-class passenger compartment would be complete without a head. A head is a nautical term for toilet. And so this has its own dedicated toilet. The throne itself is a porcelain throne. It's mounted on a hinged swing-away piece of pipe, so when it's not being used, it can be folded out of the way because space is at a premium in here. In the head there is also a hand wash basin. It's enameled cast iron, and the countertop is quarried marble. Well, this completes everything that we can show you down here. Let's go back topside and see what is left. This brass hand railing was the responsibility of the engineer. Every Friday he was supposed to polish it. He got kind of tired of that, so he painted it green one day, and the captain saw it, and he was not at all happy and said, well, you know, you can go home, but only after you have removed all that paint. This is the escape hatch that I was telling you about when we were down below in the captain's cabin. It's mounted so that the lid will swing up so the person can get out. When they put it in, they found out that they had to trim off the front edge of the lid so it would clear the backside of the ladder steps, and then they even had to trim a little bit off the backside of the ladder. This is not original. This was a modification that was done to the tug sometime after it had been here. I would say probably around the World War I era time. At the very bow of the tug, we will see a steam-powered windlass and an anchor windlass, and a casting on top that's a Samson post for mooring forward. There's an interesting thing. I have an idea about this, but I have no way of confirming it yet. There's absolutely no signs of wear on the anchor windlass where the chain would wind on. There's absolutely no sign of wear on the cylinder for the forward winch. And when I took a look down inside the chain locker, I could not see any kind of steam motor or other shaft attached to it. Further, there's no davit of any kind or a hoist for handling the 600-pound anchor. So this tug was built with this equipment, but it was never used except as a forward attachment point. Supporting my argument further about the non-use of the anchor is the hardware that supports the bumper on the bow of the tug. When the tug was built, it did not have that bumper on it, but at least from the time when this bumper was added, that anchor could not have been used because it completely blocks the fair lead for the chain. This is the pilot house. This is not the way it looked when it was first built, but this is its appearance in its later life. You see a single room with windows all the way around. When the tug was first built, this was two separate little compartments, each with its own doors, and there were no windows on the side. The after part of this space would have been the captain's own private domain, and he could have used that couch as a bed if he wanted to. The forward part is where the pilot would be doing his work, steering the tug and controlling how fast it's going. This thing that I'm leaning on is the engine order telegraph. Common name for it is Chadburn, the Chadburn, because it is made in Liverpool, England by Chadburn Manufacturing. This is an engine order telegraph. When he wants to go ahead, he would move this handle, stand by, ahead slow, and when he does, it rings a gong in the engine room and it moves a pointer for the engineer to see that the captain wants to go ahead slow. And when the engineer sees that, he will take his control lever that you saw earlier and move it to match where the pointer is pointing. And when he does, this little pointer here will move to match what the order was. And when the captain sees that, he will know that the engineer has seen the order, he has understood the order, and he's carrying out the order. Another method of signaling just used a push button and a common bell, and it was a little bit simpler and a little bit quicker. There was a push button on either side, one here and one on the opposite side. And then we had these controls which operated a little whistle down in the boiler room. If things got hectic, the captain could sound the whistle to let the stoker know that work was going to get a little bit harder. There was also a speaking tube in the back corner. So I guess you could say that we had wireless communication in the 19th century. I'm leaning on a control for the rudder. You can see it's a simple lever with a locking mechanism that engages some ratchet teeth on this quadrant down here. When the tug was built, it had a conventional spoked wheel, just like Steamboat Willie used on his tug, and that would have controlled the steam steering cylinder. When the tug was reboilered, they put in this control lever. Some thought it would be a better way of steering the tug. Some captains liked it, some captains did not. You would just release this lever and then you could move it to whatever position you wanted that corresponded to the rudder position that you wanted. When you release the lever, it stays put. This empty hole in the deck that you're seeing is where the binnacle would stand. The binnacle was a structure that housed and protected the compass. It sometimes had a light inside it so it could be read more easily at night when the cabin itself would be dark. It was a desirable item. It had what's called a high culpability, so we just took it out of the pilot house and it's on display in the museum in town here in the old depot building, along with the old original steering wheel. This lever that I'm holding in my hand is used for controlling the whistle. It's obviously of a contemporary design. This tug was used in ordinary service until 1980, so this can easily date from that era. And you would just move this lever and it would pull on this cable and it would make the whistle sound. In an earlier era, it could have been just a simple post that would secure the cable here and you would just sound the whistle by pulling on the cable. But that's maybe not quite as reliable or precise as having a lever. This lever is for controlling the searchlight that's on top of the pilot house. It has a 1,000-watt bulb in it and it has considerable reach, and it would be useful for nighttime work. You could pull down on the lever to control the angle of the light, so whether it's shining up or down, and you could swing the lever from side to side to train the light from left to right. I saw recently a letter, and it was a commendation from the company president to the crew of the tug, and each crew member got a copy. This would have been sometime in the 40s or 50s. A commercial fisherman down in Knife River was in trouble, and it was nighttime, and it was stormy, and he had a radio, but all he could do is click the microphone. When he spoke, nothing happened. All they could hear was a click in the speaker. So the tug captain figured out, he talks to the fisherman and says, "If you can hear my voice, click your microphone button twice." And so he clicked it twice. He could hear him. Then he said, "I can't see you. I don't know where you are. I'm going to sweep my searchlight back and forth. When you can see it, click your microphone button twice and I'll know which direction you are." And so he swung his spotlight back and forth until the fisherman could see the light, and when he did, he clicked his microphone button twice and the captain knew what bearing he was relative to his own position. He was able to find him and save him and his boat. What we see here is a classic piece of boat hardware. You'll see it in all the old movies. This big, tall, tuba-looking thing standing here. It's an air scoop, an air intake, a funnel, whatever you want to call it. And so what this is for is it provides air down into the boiler room for the combustion of the coal in the boilers. As the fire is going, it's consuming the air in the room, and it's getting sucked out of that room, and so it comes in through here. So there's a funnel on each side. They're capable of swinging and rotating according to what the wind and weather conditions are out here, so we don't have a lot of water and spray getting sucked into the funnels as the tug is trying to do its work. So it provides the air for combustion for the boiler. It also provides fresh air and a small degree of comfort for the poor stoker down there who's shoveling away. This lifeboat that you're looking at was built in 1907. The tug itself was built in 1896 and started work in 1897. It did have a lifeboat then, but it was a little bit smaller. They realized perhaps from the tug's operations that maybe a larger boat would be useful for some of the work that the tug might be expected to do. Ordinarily, when it was rigged for use, there would be block and tackle rigging from the top end of the davit down to the front end of the lifeboat, and another one on the other end. Then the ropes for controlling that tackle would have been tied off on the cleat here. When they needed to use the lifeboat, of course the cover is taken off, then a person would be at each davit working together, pulling on the block and tackle to raise the lifeboat. They would have to work together to raise it up so it stays fairly level and even. When the lifeboat is raised up clear of the cleats that it's mounted in now, then the ropes would be tied off on this cleat. Then the two men would have to work together because the length of the lifeboat is somewhat greater than the spacing between these davits. The tug has to be swung outboard. It can only do this by moving one end at a time. So that davit would be swung away from the stack. This one would have to be swung similarly so that the tug can move forward far enough that the davit can be swung around so the end of the lifeboat is swung around. Then this one would have to be swung around as well. And so it was a kind of a high energy slow motion ballet to get this lifeboat swung out overboard. Once the lifeboat is swung out overboard, then the two men would have to work together to lower the lifeboat down into the water. They would have to work together so that it lands in the water fairly flat. Bear in mind, this tugboat is going to be swinging back and forth depending upon the lake, and so that means that the lifeboat is going to be bobbing up and down. Again, some more high energy slow motion ballet as the lifeboat is launched into the water. I'm leaning on the monitor. That's a water cannon. So this tugboat had the ability to do firefighting. There's underneath here is a brass cannon. It's a nozzle, a big nozzle. Remember, we were talking about a special turbine pump down in the lower level engine room that would pump 3,000 gallons a minute of water. Came up through that large pipe we saw in the engine room and up into the overhead of the engine room and then across. So here it is. That pipe is probably about 9 or 10 inches in diameter. It runs up into the central column of the monitor. It comes out a nozzle on the end is maybe about 2 inches in diameter. There's enough power there that it will shoot a stream of water almost 1/4 of a mile. When we had steam engines operating on these docks, there would be hot coals, hot ash, coming out the firebox of the locomotives because that's just the way they were. They couldn't make them perfectly tight, so they're always setting ties on fire on top of the dock. When the docks were made of wood, they would set the entire dock structure itself on fire. So the monitor was a vital piece of firefighting equipment. It was so important, in fact, that during the time when the ore docks were made of wood, the insurance companies required the railroad to have a second dedicated fireboat just for firefighting on the docks. That fireboat had 2 boilers in it. One boiler for the engine, the other boiler just for the turbine pumps that provided the water for the monitors that fireboat had. It had multiple monitors on it, 4 or 5 of them. So that worked until about 1918 or so, when the last wooden dock was replaced. Then the monitor was, the fireboat was sold, and the Edna G was the only firefighting duty available on the waterfront here. So it was used for putting out fires on other boats that came into the harbor. It was used for firefighting ashore. If it was within a quarter mile of the waterfront here, the tug could do it. And in one emergency case, when there was something wrong with the propulsion system on this tug, whether it was a problem in the engine or a problem with a broken propeller, I don't know. I haven't seen the log reports on that yet, but the story is that this monitor was pointed straight aft and then pointed down a little bit so it would hit the water just above the stern of the tug, and they used that water rocket kind of propulsion to make the tug move, just to get it close enough to the dock where they could tie it up. It wasn't a great way of moving, but it was better than not moving at all. When the first mate knew that he was going to be using the monitor, he had to let the engineer know in the engine room, because he had to line up the valves to provide the steam for the monitor turbine, and he also had to line up the valves for the water that's going to be going to the pump. They also had to notify the stoker down in the boiler room. He's going to be needing a little bit more heat for the boiler. So what the first mate would do is reach down here and pull this cable to sound a bell in the upper level engine room. Well, thanks for being here. That concludes the tour. I've shown you just about everything I can think of on this tug and tried to explain it as well as my abilities permit. I'm sorry I didn't know more about the details in the engine room, but that's just the way it is. Thanks for being here.